Welcome to the Pennsylvania Trolley Museum Zoom series, Trolleyology. My name is Kristen Fredrickson, and I'm the manager of public programs and outreach here at the museum. Thank you so much for joining us today, and welcome back to those of you who have joined us for previous programs. This virtual series features programs on Pennsylvania transit history topics and stories of the trolley era, and our collection that you can experience from home, usually on a Tuesday or a Wednesday. And we plan to continue these programs regularly. So if you have a show that you'd like to share that fits our museum mission, please let me know. That'd be anything about Pennsylvania, the trolley era, or cities where our streetcars come from. And if you have a program that doesn't quite fit those guidelines, please reach out anyway. You can see a full list of upcoming presentations on our website, patrolley.org, which I can share in the chat box in just a few minutes. And I want to extend a very special thank you to those of you who donated when registering for tonight's program, and those of you who have made donations through our website this year. We really, really appreciate your support of our virtual outreach programs. For those of you who might be new to the Pennsylvania Trolley Museum, we were established in 1954 as the Arden Electric Railway by a group of trolley enthusiasts called the Pittsburgh Electric Railway Club. And the museum opened to visitors a few years later in 1963 and is actually located along the former route of the interurban line between Pittsburgh and Washington, PA. You'll find over 50 streetcars and electric railway cars here, about 20 of which operate, and about 30,000 visitors per year take the 4-mile scenic ride here at the museum. Oops. So on the left in the picture, you can see we're moving right along with progress on our new Welcome and Education Center. That's the entryway there. And on the right-hand side, you'll see the entrance to the 20th Century Electric Railway Foundation Theater. And then on the right, we have pavement in our parking lot. So this is where visitors will park and go in and buy their tickets. You can see the front of the building there with Volunteer Boulevard on the back side there. And we just wrapped up county fair operations. So you can see some of our volunteers there on the left. During one of the fair evenings, we transported over 8,500 passengers this year to and from the Washington County Fair. It's always a big family reunion. So we were excited to see probably about 100 volunteers during that week. And then on the picture on the right-hand side, you can see one of our volunteers, Bram, instructing one of his pals. We are having a new operator training session coming up in September, and also tour guide training. And if you can't make these in September, stay tuned. We'll have some again early in 2024. Okay, so that is our newest acquisition on the left. And it was like a cabin in an amusement park for a long time. So we are going to display it that way. We're going to work on it this winter, but very excited. It's always exciting to see something saved. So that's what's happening on the left there. And then on the right, this week, we are getting exhibits delivered to the new Welcome and Education Center. So we're very much looking forward to that. Everything is just happening super fast. And we're excited to keep sharing updates with you. Okay, so now I would like to introduce tonight's presenter, Tom Laurenson. He's a Scot and a retired educator who joined the Shore Line Trolley Museum 7 years ago, impressed by the work that goes into restoring and maintaining the large collection of trolleys, streetcars, and subway cars. He's now an instructor there, a trustee, and he does presentations for the museum to a range of audiences on trolleys and trolley-related subjects. And tonight, at the end of the presentation, we will have a question and answer session with the presenter, but the chat box is open, so please feel free to enter questions or comments during the show, and we can read through those at the end. And just to note, this program is now being recorded, and we will share it afterwards on our YouTube channel. I just put up the last one, which is Where the Heck is Hecla? So that went up just a few minutes before tonight's program started. All right, so everybody now please turn off your videos. I'll come along and turn off any that are still on, and we'll keep ourselves muted until the end of the presentation. I'll invite everybody to turn those on at the end. All right, Tom, if you are ready, take it away.
Yes, we're just trying to do the share part and get started. Okay, with any luck, you're seeing a welcome message, and we just push the button there to roll the screen and introduce the person that we're talking about this evening. Frank who? Well, you'll find the answer at the Shore Line Trolley Museum. His name is Frank Sprague. And somehow I've got something on... Oh, there we are. We're moving again now. This is the Shore Line Trolley Museum's visitor centre, and the name Sprague is writ large there on the wall. It's a wee bit surprising to me to find that hardly anybody in Connecticut knows Frank Sprague, because he's a local, and he, I think, really deserves to be much better known than he is. By the end of this evening, maybe you'll agree, maybe not. Let's find out. So there we are, Frank Julian Sprague. We are the Shore Line Trolley Museum, operated by the Branford Electric Railway Association. This gives endless confusion because the Shore Line Trolley Museum, according to Google Earth, is in East Haven, but only the visitor centre and the car park and a little office are in East Haven. The majority of the museum, this area here, plus most of our line, is in Branford. And the museum started in 1945 as the Branford Electric Railway Association, opened in 1947, and we now have about 100 vehicles, mainly trolleys, but we do have a locomotive or two and some subway cars as well. And this is Frank Sprague in, I suppose, middle age, still very active and looking remarkably peaceful. He certainly had a rich and colourful vocabulary, I think would be the polite way to state it, but that's maybe understandable when we learn a little more about his past. We'll look at his early life, we'll look at his engineering progress, and then some of the key developments with which he was associated. But we start with Frank Sprague being born in Milford. The house in the middle there is where he was born. City Hall is there on the left in Milford, Connecticut. It's down on the shore, just a little west of New Haven. And the bridge in the foreground is the Jefferson Bridge. Today, the Jefferson Bridge is still there. City Hall is still there. But the house where Frank Sprague was born has gone. It's been replaced by a block of apartments. And curiously, hardly anybody in Milford knows his name or knows his fame. He was born in 1857, and in 1866 his mother died. His father really couldn't cope with this and basically moved away, went out west somewhere. There were a number of Sprague relatives up in North Adams, Massachusetts, and so Frank moved to live kind of among them, but largely and mainly with his aunt. His aunt really supervised him and moved him around the relatives, but he spent a great deal of time with her. And he did very well at school despite all this disruption. He did particularly well in mathematics and in science, and decided it would be a good move to sit the entrance exam for the US Army, which required you to go along and do a couple of days of tests. Well, he kind of got it wrong, because when he arrived there, he discovered it was the exams were for the US Navy, not the Army. And he did very well. He was first in a group of 13 who sat these exams and promptly joined the Navy. And after some training at Annapolis, including a fair amount of electrical engineering training, and it was fortunate that he joined the Navy, because the Navy at that time was offering better electrical engineering training than the US Army was, and indeed it was among the best in the country at the time. In his relatively short career with the US Navy, he served on 3 ships. All of these were sailing ships with steam engines, or you might call them steamships with sails, but I think the former is more accurate. The US Navy at the time hadn't fully committed itself to steam engines. Indeed, it didn't do that until the 1880s. So he was out in the Pacific for a while and then in the Atlantic with these 3 ships. And he started inventing straight away, inventing ways of sending signals from the bridge to the engine room, for example. And then in 1881, he managed to get some leave and he set off to France to the first international exposition of electricity. This is a time when electricity was still a new thing. It was a new development and all sorts of discoveries were being made. And Paris and then the following spring, London, were really the places where the leading edge technology, electrical technology, was on show and on display. Of course, going to the Paris exposition and then the Crystal Palace exhibition meant that he overstayed his leave somewhat considerably. And so when the young officer arrived back in the US, he had the anticipated interview with his commanding officer, who was not happy. But Frank was able to produce leaflets, booklets, all sorts of material from both of these exhibitions. And his commanding officer and others realized that really they'd missed out by not having anybody else at these exhibitions. And Frank Sprague had brought back some very valuable material that would help the Navy. So he didn't go to jail or anything, or well, it's not jail in the Navy, is it? He was the brig, I think they call it in the Navy. He didn't go there, but the following year he left to pursue a career, at least for a short time again, with Edison. And shortly after that, he left. He didn't spend a great deal of time with Edison, and this is his letter of resignation, and the bit here in the middle is the bit that's of interest. He's basically saying to Edison, yep, you wanted to make yourself famous. I want to do the same, and I can't do it with you. And that's not too surprising. Edison at the time was preoccupied by trying to get electrical lighting into the streets of towns and cities. And that's a few years later, but this is one of his dynamos, 1.6% efficient. Can you imagine putting a horse worth, that's not a horsepower, but a horse worth of energy into the system and you get out a Jack Russell Terrier? That's the kind of scale of things. Edison's approach was basically try everything under the sun until you find something that works. It really was not a good system. But Sprague was able to basically transform the research and development practices of Edison. Edison's approach was to take a large warehouse, to lay out wires in the street pattern of the town or city that he was trying to light and have little light bulbs scattered along it, and put a battery roughly in the middle somewhere and have assistants crawling around measuring the voltage along these wires. And then they'd move the battery somewhere else and crawl around measuring the voltages. And this took a lot of time and a bit of money. But that was Edison's technique. Frank Sprague took one look at this, sighed greatly, I would imagine, pulled out a sheaf of paper, a pencil, and a slide rule. If you're under 50, you've probably no idea what a slide rule is, but it was the calculator of the day. And in a morning or so, calculated where the best place for the battery, in other words, the power station, would be. And that showed the Edison organization that they really were approaching research and development the wrong way. That was one huge favor that Frank Sprague did for the Edison Corporation. He went on to show his interest in electric motors. That was his first initial project. And that was important because factories of the day were still using a single energy source. The Industrial Revolution started with water wheels powering a whole factory. And by this time, by the 1880s, 1890s, steam power had taken over. And so outside there would be a huge steam engine and the shaft would be coupled to gears, and eventually the power would be transmitted through these shafts and through these wheels and down the belts to operate the various machines. So the whole factory depended on this steam engine. You couldn't just use half the machines in the factory. That would be horribly inefficient. And it was relatively difficult to adjust the speeds. You pretty well had to set the speed with the size of the wheels and the belts to get the speed that you needed for a particular machine. But Edison recognized that Frank Sprague had made huge advances in developing electrical motors, and the factories really needed this kind of thing. This was at the Philadelphia exhibition just after Sprague had left, and this is the kind of motor that he came up with, one of his early motors. He had no manufacturing facilities of his own, so he used Edison's manufacturing capabilities, which sounds like a good idea, but maybe wasn't. And here's the kind of thing that could happen. You put the motor somewhere and you can drive 1 or 2 or maybe 3 lathes, drills, whatever you've got in the factory. And by having a number of these, you can switch on as many or as few as you need. And you can adjust the speed so that you can do different things. You can be more precise, perhaps, in what you're doing. This is one of Sprague's motors. It's actually in our visitor centre. And a few years ago, we did put some wires to it, put some energy into it, and it worked. So we have every reason to believe it'll still work, but we haven't tried it for a while. And so let me just finish on that. The big advantage of this motor is that this thing is about the size of a small microwave oven. Comparable motors of the time were about the size of a refrigerator. And if you think in terms of trolleys, a thing the size of a refrigerator has to sit on the floor. This could go underneath the floor. We'll come back to that shortly. This illustrates Frank Sprague's approach to inventions. Whenever he came up with something, he would draw it. He would have it signed by himself and another witness. He would date it and he would have it witnessed. So he was very protective of his inventions, as you might expect. And we'll see this particular one come up a wee bit later. The motors were immediately put to use in the trolley system. This is our oldest exhibit at the Shore Line Trolley Museum. It goes back to about 1855. It's a horse-drawn streetcar. It looks very much like a Wild West stagecoach, and indeed it's not that different from a Wild West stagecoach. The driver sat up here. In the case of New York, as far as I understand it, they didn't have a guy with a shotgun sitting beside the driver, but these days, if they were to do it, they might. And people came on and off through the back rather than at the sides in the Wild West, in the case of the Wild West stagecoaches. But this is a horse-drawn, and these things became very, very popular because you needed only 2 horses to drag quite a considerable weight on rails compared with the 6 horses you need on a stagecoach. Never mind the hills and dales, just the routes were very, very rough, and so you needed that kind of a power. But horses have their problems. They can work for only a certain proportion of the day. They need constantly to be fed, and what goes in must inevitably come out. So finding a cleaner solution to powering these streetcars was certainly something that was going to prove very, very popular. And there were various attempts being made. One was in Russia, one of the earliest that we know of. The one in Germany is particularly interesting. The Blackpool tramway still exists. It's not the original rails or vehicles, and it's a little tourist attraction along the seafront. The one in Germany, though, this is a photograph of it, and we're seeing a fairly small streetcar, a conductor at one end, an operator at the other end, but no pole. This one ran with a positive rail and a negative rail. And here we can see more clearly in this sketch that there's no pole. The voltage here was 400 volts DC. It didn't take long for the teenagers, being teenagers, to find that if you had a piece of wire or a bit of chain and you threw it across the tracks, you'd get some interesting sparks. And look at the lady on the right with long dresses that go down to ground level. Walking across there in wet weather would give that lady more excitement than perhaps she could handle on a given day. So a bit dangerous, basically, and not terribly powerful, but it ran for about a mile or just over a mile on almost flat land. So it didn't need all that much power, really. And this is a locomotive from about that time. Again, it's on display at our museum. It ran not far from where we are, and it had a Vanderpool motor. And this is what it looks like. It's huge. It's the size of the refrigerator. And the wheels here transmit the drive over here, and then a chain drive takes the power to the axle. As the locomotive bumped up and down the track, the chain would quite frequently disengage. So there were two problems here. First is the size of the motor. It's only 26 kilowatts, and look at the size of it, and the chain drive. And the third, I suppose, it's sitting on the floor level, taking up what would be revenue earning space. But it is only a locomotive. Frank Sprague's answer was something like this. His answer was to put the motor right down on the axle, driving the axle directly. As the axle flexed up and down, so did the motor. So the drive was maintained. The power to the axle, to the wheels, was maintained. And this drawing shows a power wheel, a third rail, picking up the power. This was abandoned fairly quickly, but it's the most reasonable drawing I can find that shows what's called the wheelbarrow design, where the motor sits on the axle with the gears there, the driving gears, in constant contact. And Frank got a contract, against all the odds, to build a system in Richmond, Virginia in 1888, the year that Vanderpool's locomotive was built. This was quite a challenge. He was required to build some 12 miles of track through the city and provide about 40 vehicles. And although this is exaggerated, the vertical scale is exaggerated, you can see that it did have to go down into a valley and up the other side. That's in this area here. He has to go down into the valley and up the other side. And this is something that just had not been done before. This is roughly where it is relative to modern Virginia. There are one or two places where the original rails can still be seen. And this is one of his first cars. Here we've got the first real use of the trolley wheel. And that's what gives us the name trolley cars. We can see it's double-ended. We can see a single truck underneath. And we can see the controller and a handbrake, a hand-operated brake. And this gives you an idea of the gradient. I imagine that both the operator and the conductor are hanging on to that brake as much as they can, because this thing is heading downhill, not with too much of a load, but still getting that thing to stop on the hill must have been a little difficult, to say the least. And we can get an idea of why this was so popular from these two shots. We're looking at the hill part of Richmond, but look at the quality of the road. It's rough, it's uneven. By comparison, the trolley tracks must have been much, much smoother, much more comfortable. And here the road is even worse. It doesn't even look as if it's cobbled. It almost looks as if it almost looks like a stony beach. But certainly to walk on that, to take a cart on that, clearly wouldn't have been comfortable. One of the things that Frank Sprague was asked to do was to demonstrate that there was enough power to have all 40 vehicles going at the same time. And so he lined them all up and sent them off one by one. We are told that the gentleman in the power station was told that the cutout switch was to be sat on and was not to cut out under any circumstances. And it's possibly in the Navy, the US Navy, that he learned the rich and colourful language which accompanied this instruction. At least we're told it accompanied this instruction. Frank Sprague was a man of great genius, I think, but he was also a man of very short temper and language associated with that temper. But the experiment succeeded, the demonstration, I should say, succeeded. The city authorities were satisfied and the system operated. And it operated successfully. It was only in 1949 that it ceased. So he met the challenges that other streetcar systems hadn't. He had distance, 12 miles of it. He had steep grades to negotiate, and he managed that. It was a reliable system. It had to work every day as people relied on it to get to work and so on. And it was profitable. It did actually make money. It paid for itself. It's little wonder that in the 2 years after this system was put into operation, some 200 cities across the world were clamoring to install the Frank Sprague system. In America, cities from Toronto to Buenos Aires put them in. Buenos Aires becoming for a while known as Trolley City because they had something over 500 miles of trolley line within the city boundaries. And the trolley lines didn't just serve the towns and cities, they began to connect neighbouring towns and cities, usually over fairly short distances. But let's consider the plight of this gentleman standing by the road. I like to think that he has a somewhat forlorn look on his face. He certainly, his stance suggests that. But the road is dirt, negotiated by horses and carts. He's standing there waiting. He doesn't own a horse, so he can't go on horseback. He may have been at one time waiting for a horse-drawn cart to take him where he's trying to go. But now suddenly there's a trolley line there and a trolley offering speed, offering cheapness, offering comfort, offering protection from the weather, and arriving frequently enough to be useful to him. So it's little wonder that people clamoured to install trolley systems and began to use them in huge numbers. Many cities still have their trolley systems. Here in Connecticut, there are no trolley systems left. For some reason, New Haven and the other areas abandoned their trolley systems, but other cities had different reasons for maintaining theirs. And there are many cities, as I'm sure you know, who are installing new systems or have modernized their systems. Seattle alone has built 2 new trolley lines in this century alone. So trolleys may have died in Connecticut, and that's one battle we have to fight at our museum. But elsewhere in the world, they still serve, they still offer the advantages of cleanliness and comfort and so on. And increasingly in an environmentally sensitive world, they offer the absence of diesel or gasoline-powered engine fumes. And they're quieter usually too. This is about the period. I mean, here's 1886. Frank Sprague hadn't yet got his contract for Richmond, but Mercedes-Benz were producing the first automobile. But look at it. I mean, it's pretty small. And even by 1888, although they'd made it a little bigger, it certainly wasn't terribly powerful. It certainly wasn't terribly reliable. It was a few years later that the first US automobile came on the scene. And this is obviously a horse-drawn buggy with a tiny little engine tucked in behind the driver on the platform there. Instead of the shafts for the horse, as the horse moved to the side, the shafts would turn and that would provide steering. They've replaced that with a rod that the driver turns from side to steer it. I don't imagine the turning circle would have been terribly small, but this kind of vehicle hit the streets, and even here we've got a chauffeur operating it, and of course a little alarm thing to encourage people to get out of the way. But these things were small, they were not terribly powerful, they were not terribly reliable, and there was a great deal of resistance at the time to this highly dangerous fuel that these things were going to use. Coal for steam-powered engines was nothing like as combustible as gasoline. Having succeeded in developing a new form of transport with his new motors, Frank Sprague turned his attention to elevators. Elevators at the time were either hydraulic or, in this case, rack climbing with an electric motor powering it, but they were pretty slow, couldn't take much weight, and it was difficult to get them to stop at just the right place. Enter Frank Sprague. And he formed the Electric Elevator Company, again using Edison's manufacturing facilities to get him going, because Edison had the manufacturing. And he was very successful with this company. He formed it in 1892, and he sold it just a few years later to Otis. And Otis had developed, Otis developed a safety mechanism so that if the rope, the wire broke and the cage, the passenger compartment was to start sliding down, the Otis development would stop it in its tracks. But Frank Sprague made it happen in the first place by developing the motors and the control systems that allowed you to take it to a particular floor and stop it in the right place. And with that kind of elevator possible, we get the high-rise buildings that began to dominate the New York and other skylines. Until then, buildings in New York basically were limited to about 5, maybe 6 floors. And there were 2 reasons for that. The first is the human reason. If you're having to climb the stairs with all your groceries, with your bags of coal, with your kids, with your furniture, with anything that you want moved into your apartment, 5 or 6 floors is about as much as you're going to want to go up. The second reason was that New York's water supply by now was coming from the Adirondacks, and the water pressure that was available in New York City would take you up about 5 floors. Above that, you needed water towers and pumps and so on, and so they built to about the 5 floors. If there was a dip in the landscape, they could go higher, but about the 5 floors. Suddenly, with this new elevator technology, enormous buildings could go up. And we can see this sort of scale of development. 31 floors for that Park Row building. And then a few decades later, we get to the Empire State Building. And now we're up to something like 163 floors. The tallest building is in Dubai. Built on sand, so I'm not sure just how stable that is. But there is a problem with these buildings, and it's not the technology, it's the cost. The higher the building, the bigger the percentage of space you're using for elevators. And that really isn't revenue earning space. So you either have to charge a small fortune for the height, and in Dubai, at least people have the money to pay for that. But it's a problem. And it's not a problem of the technology. We can build elevators to go that high. It's just that it becomes uneconomic. So this is Frank Sprague, by now well established as an inventor and scientist. But he still doesn't look terribly happy, does he? He still looks a wee bit on the fierce side. He turned his attention to multiple control. And here's the kind of problem that cities were facing. This is the Bowery in New York City. And trains were arriving to bring people into the city, and this is a steam engine, as we can see. And steam engines are heavy and powerful, and so they can pull 4, 5, and 6 cars behind them. But they also generate a great deal of smoke and a great deal of noise and a great deal of dirt. And having those passing by your windows is not much fun. You can't really put them down at street level. It's a bit dangerous down there, so you have to put them in some kind of segregated context, and in this case, it's an elevated track. Down in the street, we've still got horse-drawn traffic, and maybe you can make out in the middle of this track the little area, the slot for the cable, because these early cars here are cable cars, like the San Francisco cable car, with a cable running through here and the car reaching down to grip the cable in order to go, or let it go to stop. These slots are kind of vulnerable, especially if you've got horses on the streets as well, but rain gets in, washes mud in, and so on. It's not the best of solutions for city streets, but at least for a while it was the answer that they used. The electric trolley certainly made its presence felt in New York quite quickly. But here's the second problem that the city faced: steam engines coming into, in this case, what was called at the time Central Station. And that's fine. The station worked quite well. All these trains arrived, pulled by steam trains. But that's a huge amount of space in a city where space is pretty valuable. And people wondered if there was a better way of doing things. And things came to a crux, because to get to Central Station, you had to come down Park Avenue. So we're looking north here, up Park Avenue, and way to the north, there's a hill that the railway couldn't go over, so they had a tunnel through it. If you know New York, you leave 125th Street at Harlem, and within a few minutes, you're into the tunnel that leads you down towards what is now Grand Central Station. It was in that tunnel that there was a fatal accident. A steam train went in, filled the tunnel full of smoke. The following train couldn't see the signals and ran into the back of the first train, and there were a number of deaths. And so the city decided that they would have to electrify the lines, because that technology was now becoming available. The second advantage of this was that you could build over the station. Now that you didn't have to have it open air because of the steam, with no smoke to be dealt with, you could build over and produce some highly valuable real estate. So some years later, things were underway. We can still see that little bit of building on Park Avenue, so we're still looking north up Park Avenue, and they're digging deep into the ground to get lower level tracks. And they did all this while still maintaining service, which is quite remarkable. I'm not sure if that could be done today, because computers would be in charge instead of people. But they were able to do it in those days. And one of the key things that they needed, here we're seeing the area gradually being covered over, but one of the key things they needed were really effective electric trains. Now, remember that drawing we saw of Frank Sprague's invention? Here it is again. These things there are the things that Frank Sprague invented. More than 100 years later, Frank Sprague's inventions are still lining the track, running into Grand Central, because this is where the line starts to go into that tunnel after leaving the 125th Street station. And the problem that many engineers had is that trains were things that were pulled by steam locomotives. And if you think in terms of steam locomotives, you think of a vehicle at one end hauling passive cars. But Frank Sprague thought we should be able to do this with cars with electric motors. And other engineers thought, well, what you have to do then is to have a car at the beginning, a locomotive with all the power going through that, and then you send the power to all the other cars in the train. Frank Sprague realized that you didn't have to do that. What you had to do was to send the control signal to the other cars. They could be powered in the usual way, or the power could make its way down, but what you had to do is send control signals to the other cars, not control the power to all the cars, because by the time it got to the last car, the voltage is going to be slightly different. So he found a piece of test track up in Schenectady in upstate New York, and he set up this experiment with two cars. They were linked by the control cables, they were linked by the air hose for the brakes, and that was it. There was no physical coupling. And it worked. And with this development, multiple control electric trains became possible and could start running into New York. Although the first commercial application of this was actually in Chicago, because Grand Central wasn't quite finished at that stage. This is the principle still used. This is Metro North, which runs into Grand Central and out to New Haven and up the Hudson River and so on. And again, we see Frank Sprague's little invention here holding the third rail. The same principle is still applied for the high-speed trains that we find in China. There are something around 26,000 miles of high-speed train in the world today, half of it in China, virtually all of the rest of it in Europe. There is one line, I believe, in Morocco, in North Africa, and so far nothing in either of the Americas, north or south, which seems a wee bit strange. But the same principle is also applied here. This is from the Netherlands, and since April 2016, they've been using multiple control for trucks. The first truck has a driver in it. The other two don't. The control signals are sent from the first truck to the other two. And this is not to say that they all accelerate and brake at exactly the same time. But essentially what happens is that the second and third trucks follow the first, but they have their own override in that if the first one goes through the lights at green and the second one arrives and the lights are at red, it will stop. It won't just carry on. But it will then, when the lights go green, follow the route taken by the first truck. If the red car back here was to slide into this space, the third vehicle would pull back. If this red car was to then come back into this lane, the third vehicle, the third truck, would close the distance again. So this is effectively Frank Sprague's development taken into the 21st century. It's multiple control with the control signals being passed to the individual vehicles in what we have to regard as a train, a road train. And today, the trolley systems, well, we can't really call them trolleys because this one doesn't have the trolley pole, but streetcars. This is the latest development in streetcars. Since, again, 2016, the Chinese have been building streetcars not powered by overhead cables with trolley poles, but powered by batteries. And they can run on rails, as here, or they can be built to run on the roads. And the batteries they use aren't the lead-acid batteries that you use in your car, as long as it's not a Tesla. They use supercapacitor batteries. Lead-acid batteries, as you know, are not too good in really cold weather. Your car battery can be a bit sluggish in cold weather, but supercapacitor batteries aren't. They're not chemical batteries. There's no chemical reaction involved. And whereas lead-acid batteries will store the electricity for a long time, but take a while to charge, supercapacitors don't store it for terribly long periods, but they charge up quite quickly. The Chinese, in a city whose name I can't pronounce, but it's not far north of Hong Kong, have supercapacitor batteries, and the streetcars get to a stop. There's a little overhang with a rail below it, and they reach up to the rail, and in 20 seconds they can refresh the charge that they've used since the last stop. They carry more capacity than just one stop at a time, but in 20 seconds they can recharge. If they miss 2 or 3 stops for some reason, it takes maybe a little longer to recharge, but not a huge amount of time. I think Frank Sprague would approve of that. Here's his timeline. 1857, just before the Civil War, joined the Navy, but didn't stay with it for terribly long. Joined Edison, but really didn't stay with that for terribly long. Got his contract for Richmond and must have made a fair bit of money out of 200 contracts for trolley systems. Then moved to elevators and multiple control, particularly focused on electrifying the lines into what is now Grand Central Station. But his influence continued. It's interesting that in 1889 he won a gold medal at the International Exposition of Electricity. Remember, he was at the first one in 1881. So in only 8 years, he went from a young naval officer overstaying his leave to harvest all this electrical knowledge and developments. And 8 years later, he's winning a gold medal at that same exhibition. And he won a range of other awards during the course of his lifetime. And this is him again. It's impossible to find a picture of this man smiling, but he must at some time of his life done that. But he was serious about his work. He was serious about his inventions. And there's a range of other things that he invented, including a number that were triggered by the First World War. He invented a number of wartime applications of electricity. And we recognize his contribution and certainly acknowledge him here at the Shore Line Trolley Museum. But there's a little PS to this story, which I find quite interesting. Frank Sprague had a son called Robert, and Robert went on to develop the Sprague Capacitor Company. And I find that a little interesting that capacitors or supercapacitors are what now power these modern Chinese trolleys, which are catching on and becoming quite popular. So that's one little loop, one little tailpiece to the story. But there's a second. Sprague capacitors were made in this building. And this building is in North Adams, Massachusetts, which, if you recall, is where Frank Sprague went to school, in a building not terribly far from this. And this building is now the Massachusetts, it's MassMoCA, the Massachusetts Museum of Contemporary Art in North Adams, Massachusetts. So it seems to me there are two little tailpieces that intriguingly complete the story of Frank Sprague. And if there are questions, I will do my best to answer them. I might even know the answer to one or two of them. You never know.
Thank you so much, Tom. We will get to questions shortly. You're welcome to share those in the chat, or I will also let everybody unmute themselves in just a minute. Before everybody skedaddles, I did want to let everybody again know about the upcoming tour guide trainings and new operator training at the Trolley Museum, Pennsylvania Trolley Museum, I guess I should specify. And also, our next Trolleyology is scheduled for October 10th. We may be able to fit one in September. I'm not sure yet. But right now, the next one will be Cemetery Transit, a history of death riding the rails. So that should be a different kind of presentation. So thank you all again for coming. I just wanted to also mention we've got the Terrible Trolley Towel officially licensed, available in our store, and also our 2024 Western Pennsylvania trolley calendars. You can see those on our website. There's a store tab at the top of patrolley.org, which I'll share again in just a minute. Thank you again for joining us, especially those of you who donated. At this time, I welcome you, or I invite you to turn on your videos. And let me see. I did share the link for Shore Line Trolley Museum in the chat as well. So definitely check them out. Go visit if you're in the area. There is like a Trolley Museum reciprocal membership. So if you're a member of PTM, then I'm not exactly sure what it is off the top of my head, but let them know when you visit Shoreline. Some very nice comments coming in to the chat. So let me make it so everybody can unmute here. Okay, you should be able to unmute, which, if you're not familiar, is typically in the bottom left of the screen if you're on a computer. So feel free to unmute if you have anything to say. I know Frank Sprague has inspired many trolley museums for various naming opportunities, right? You guys, your visitor center, I think I heard Scott Becker, our executive director, say earlier that was like the first visitor center of like any trolley museum. And then our own Pennsylvania Trolley Museum, our resident cat was named Frank. He passed in, I think, 2018 before I started working there. Does anybody have any questions? Lots of nice comments coming into the chat. Feel free to unmute yourself.
Hi, Tom. This is Andrew Lugassi. I'm a member of Shore Line. Sorry, Kristen, not a member of Pennsylvania, though.
That's okay.
I had a question for you about the sources for where you put this together. There's the book by Middleton, and there's another one about Sprague. Did you use either one of those?
Yes, there's some material in the New York Public Library as well. If you go in there, there's a couple of books, and there's a tiny little book written, I think, by one of the Sprague family, which talks about the discord, if I can put it that way, between Sprague and Edison. Edison being the let's try everything under the sun to see what works, which he did with light bulbs, for example, as against Sprague, who was the mathematician and theorist and who could calculate the results. So yes, I used a variety of sources.
Yeah, I was going to say the interesting thing for me, because in the Middleton book, is the end, where at the end of his life, he wanted to come up with what is now, I would say, the analog version of positive train control, and how he was defeated by the railroads from managing to actually implement something like that.
Yes, he was active as an inventor all through his life. I just picked out some key points, but yes, he was. I mean, not every invention worked, but he was certainly active all of his life.
It was a great presentation. Thank you.
Thank you.
One thing I'd like to add to with Frank Sprague, his success, particularly with the Richmond trolley system. There's another traction pioneer who is even less known than Frank Sprague, and that is Charles Van der Pol. And there were three elements that Van der Pol developed that were essential for trolleys to work. One was the idea of putting a wheel on the end of a long steel pole and have it sprung against the wire. The other, another one, was the overhead wire fittings that made curves, crossings, and switches all possible and practical. And then in the motor itself, it had been the practice of using brass brushes, which, of course, brass against brass, wore out quickly. So he came up with the idea of using carbon brushes, which, of course, which is still used today. So even with somebody not as well known as Frank Sprague, there was still another man behind the scenes.
Yes, there were lots of people developing parts of what we might call the electrical infrastructure at the time. I mean, it was a rich field. It was the new technology. It was exciting. So all sorts of things were being developed. I think Frank Sprague's genius was to put it all together in the case of Richmond, that he was able to take advantage of all that. There were other, I mean, you're right, Van der Pol made the first practicable trolley system, but there were other experiments earlier, one or two that had the wheel going on top of the wire, which was interesting. Yeah.
Well,
but yes. Sprague wasn't the only man to invent things at all.
Plus, the conduit system is in Washington, New York, and a handful of other cities in the world.
I'm sorry, I didn't quite catch that one.
The conduit system, as in London, Washington, D.C., New York City, and a handful of other cities. Too expensive to be practical, really.
Yes, they maintain it in San Francisco because of the hill.
Oh, no, that's cable car. I'm talking about electrical, positive and negative control.
Oh, right.
In what amounts to a cable car slot, although a lot shallower. I was wondering about the overrunning third rail. Every post-World War II new system in the United States, to my knowledge, has been overrunning third rail rather than underrunning. I'm not too sure about Honolulu. Why is this the case if underrunning third rail is so superior?
Well, for one thing, even though underrunning third rail is safer, the fact that you can protect it better, you need a spring to hold the shoe against the rail on the underside, whereas an overrunning third rail, the shoe runs along the rail by gravity.
It seems that the marketplace has gone with the competition, one might say. Interesting story.
A comment from the chat. Does anyone know, Tom, do you know if Tesla and Sprague overlapped at all when working for Edison?
I couldn't tell you for sure. They were obviously working at about the same time, but I don't think Tesla certainly had lots of patents. Marconi developed the first radio largely based on Tesla's patents. So it's entirely possible, but I really don't know if they ever met or worked together.
Yeah.
I haven't come across any references to suggest that they did.
Okay.
There was another interesting thing. Edison took personal credit for all of his inventions and tried to block out, if you will, people like Sprague. They published Edison Institute, waited till Sprague died, and published a pamphlet which talked about all of the great economic benefits of electricity and attributed all of that to Edison rather than Sprague. For example, inventing the electric dynamo. As a result, after reading this, I lost a lot of respect for Edison.
Yes, when Sprague sold his motor business basically to Edison, who was manufacturing them anyway, the first thing Edison did was to make sure that every single motor was stamped with the Edison name rather than the Sprague name.
Right.
Yeah, like you showed the patents had like the witnesses and everything. Yeah.
Yes, he was meticulous in always doing that. No matter how trivial the invention or development might seem, he made sure it was recorded and witnessed and dated and everything. Yeah.
Wow.
Yeah, the other thing about Edison, he was very meticulous about protecting his patents. Yet, from what I understand, he hired a young engineer or mechanic from Germany who worked for the man that invented the best vacuum pump in the world at the time, hired him, had him build a duplicate of it, and that's where he got his good vacuum to actually make a successful light bulb. And of course, gave no credit to the German and just took that thing. But hearing the story about Sprague, I work on radios, and I've always seen the Sprague name on the capacitors and things. So it was interesting to hear that was his son that started that. That was a nice bit that added to my knowledge. Thank you. Good presentation.
Thank you. You're welcome. Oddly enough, it's the first place where I came across the name Sprague. I was familiar with Sprague capacitors long before I got to the Shore Line Trolley Museum.
Near the Seashore Trolley Museum is a factory and business called Sprague Electric. And I wondered if that was connected to Frank Julian Sprague. I have no idea. They couldn't tell me.
I couldn't tell you either, but I know that there are still, remember Frank Sprague stayed with a number of family members up in North Adams, and there are still a number of Spragues in the Massachusetts and Boston areas. So it's possible. It could be a descendant who is an electrician.
Okay, any other questions or comments for Tom before we wrap it up tonight? All right, I thought that was fascinating. I did not learn about Frank Sprague in school. I learned about Edison, but I didn't learn about Frank Sprague. So I think that's, you know, all part of the lesser known history that these programs are really good at teaching us about. So thank you so much, Tom. We really, really appreciate you sharing your program with us tonight. And I appreciate Shore Line Trolley Museum also posting it on their website. So thank you very much. And thanks to all of you for coming tonight. We really appreciate it. I hope you can join us for the next one. And I hope everybody has a wonderful rest of their week. We'll see you next time. Thank you.
Thank you. Good night, Kristen, and thank you.
Good night.
Thank you.